Good afternoon, everyone. My name is Anmol, and today we are discussing our four topics named as uniform circular motion. Second one is centripetal force. Third one is circular motion of a car on a level road, and fourth one is circular motion of a car on a banked road. So, without wasting any time, let's start with our first topic, named as uniform circular motion. So, circular motion can be of either of two types, uniform circular motion and non uniform circular motion. Basically, in uniform circular motion, speed is constant but velocity changes it at each and every point, right? Whereas in non uniform circular motion, speed and velocity both changes. So, our point of discussion here is only uniform circular motion. So, if a particle is moving in a circle, it must have some acceleration acting towards center, which is making it move around the center. Since this acceleration is perpendicular to the velocity of a particle at every instant, it is only changing the direction of velocity and not magnitude. That's why the motion is called uniform circular motion. And we call this acceleration, which is helping the particle to change its direction, we call it centripetal acceleration. And other name is and the other name of this acceleration is radial acceleration. The force acting towards the center is called centripetal force, right? So in case of a non-uniform circular motion, the value of acceleration will be a equals to v square upon r. I hope you all know the derivation of this formula. So let the particle which is performing the uniform circular motion, its mass is m. So the force will be over here, will be m into a, according to the second law of motion, right? So if we will put the value of the acceleration over here, then the value will be m v square upon r. So what we have to know here over here is that the particle performing uniform circular motion, its speed is constant, and the second one is its velocity is changing at every instant. And third point to be noted over here is there is no tangential acceleration, right? Why? Because due to tangential acceleration, the speed of the particle increases and decreases, and so the value of tangential acceleration at uniform circular motion will be zero. I am writing in a short. So the value of tangential acceleration at uniform circular motion will be zero. Our second topic of discussion over here is centripetal force. So, what is centripetal force? As we have discussed over here, a force required to make a body move along a circular path with uniform speed is called centripetal force. And as you can see over here, this force always acts along the radius and towards the center. So, a force continuously deflects the particle from its straight line path to make it move along a circle. And we have derived the formula of this force also. So F equals to basically mv square upon r. So what are the examples of centripetal force if we say? For example, if a stone rotated in a circle, the tension in the string provides the centripetal force. Right? This is the first example. And the second one is the, for example, if a car taking a circular turn on a horizontal road, then the centripetal force is provided by the force of friction between the tires and the road. And third one is the around regarding the motion of the planet around the sun. Since it is the gravitational forces that is exerted between the sun on the planet that helps in for the centripetal force. So centripetal force is not a new kind of force. The material forces such as tension, gravitational force, electrical force, friction may act as a centripetal force in any circular motion, right? So let's go with our third topic, circular motion of a car on a level road. So as you can see over here in the figure, this is the rough diagram. When a car moves a curved level road, the force of friction between the road and the tire provides the centripetal force required to keep the car in motion around the curve. Let consider a car of weight mg. This is the mg, right? And this one is the force of friction for the first tire, and this is the force of friction for the second tire. Both are acting inward, and this is your normal force r1, and this is r2. So basically this is r1 plus r2. So while taking the turn, the tires of the car tend to leave the road and go away from the center of the curve. The force of friction F1 and F2. F1 and F2 act inward at the inner and the outer tires respectively. If R1 and R2 are the reactions of the ground at the inner and outer tires, then the value of the friction force will be F1 equals to mu R1 and F2 equals to mu R2. Whereas mu is the coefficient of friction, right? Coefficient of friction between the tires and the road, right? So total force of friction will be total force of friction will be uh, f1 plus f2, where we will put the values of f1 and f2. So it will be mu r1 plus r2. As you can see over here, the normal reaction force balances the weight of the car. So r1 plus r2 is equals to mg. So mu equals to mg, right? And for the car to stay on the road, the maximum force of friction must be equal to or greater than the centripetal force. So, and one point to be noted over here is that the car is moving with constant speed v. Car is moving with constant speed v, right? So we can say the acceleration of the car is zero. So mu mg must be greater than equals to mv square r. This is the condition, right? The maximum force of friction must be equal to or greater than the centripetal force. So we can write over here, cancel the value of m. So v square upon rg is less than equals to mu. So v square equals to less than equals to mu rg, or we can say the maximum speed over here is mu rg. So if the speed exceeds the v maximum, the car will skid and go off the road in a circle of radius greater than r. This is because the maximum available friction is insufficient to provide the necessary centripetal force. So clearly, the maximum safe speed Vmax depends upon the value of r, that is radius of the curved path, and the coefficient of friction between the road and the tires. And generally, we see that in rainy season, the friction decreases, and and the car gets skidded if we drive, with maximum speed, or we can say if we drive in a out of limited speed. So our next topic is circular motion of a car on a banked road. So you must have seen in hilly regions that the outer edge of the curved roads nearly at a higher height compared to the low inner portion. So why we do this? So let's go into the detailed study. So the large amount of friction between the tires and the road produces considerable wear and tear of the tires. So to avoid this, the curved road is given an inclination sloping upward towards the outer circumference. So we generally what we do, we provide we make the outer region little bit higher, and this is called the banking of the curved road. And why we do this? Just to reduce the wear and tear of the tire. So the system of raising the outer edge of a curved road above its inner edge is called the banking of the curved road. And the angle, let this is the theta, and the angle through which the outer edge of the curved road is raised above the inner edge is called angle of banking. So as I have shown in the figure, let's see the how many forces are acting on it. And you know what we will do, we will resolve all the forces. So let's go with the first of all, weight mg will act downwards, right? This is the normal force r. So if this angle is theta, then our this angle, right, will also be theta. I hope you all know how to solve the components in the previous classes. R cos theta, this will be r cos theta, and this will be r sin theta, right? So as we all know that the friction is acting inwards, so let's resolve the components of the friction also. So this is our friction F, and it will have two components. One is acting towards the r sine theta, and one is acting bottom vertically downwards along the weight. So this is will be the angle theta, and so this will be the F cos theta, and this will be F sine theta. So the forces acting on the vehicle R will be, so how many forces will be acting? First one is weight mg, that is acting vertically downwards. Second one is normal reaction r, normal reaction r of the road acting at an angle theta with the vertical, right? And third one is our force of friction F. So this is the force of friction F acting downwards along the inclined plane, this one, right? So equating the forces along horizontal and vertical direction respectively, and balancing all the horizontal and vertical components, what we will get, let's see. So first we will balance the, this sine theta, r sine theta component force. So r sine theta plus f cos theta, because f cos theta is also acting in the same direction of r sine theta, is equals to mv square upon r. And what is mv square upon r? This is the centripetal force. And second one, this will be our first equation. Second one is mg plus r cos theta equals to mg, I'm so sorry, mg plus f sine theta equals to r cos theta. So what we will do, we will just solve this one, put mg, put this mg on this side and f sine theta on this side. So we can write in this form also, mg equals to mm, r cos theta minus f sine theta equals to mg. So this will be our second equation. So what we will do, we will divide equation 1 by 2. So dividing equation 1 by 2. So r sine theta plus f cos theta upon r cos theta minus f sine theta equals to v square upon rg. Dividing numerator and denominator, dividing numerator and denominator of LHS by r cos theta. So what we will do, we will divide this component. So when we will divide r sine theta with r cos theta, r will get cancelled out, and sine theta upon cos theta will change into tan theta, right? And f cos theta upon r cos theta will cancel out, it will give you F upon R. Similarly, over here also, we will get the value of 1 minus F upon R tan theta equals to V square upon RG. You all know that the friction formula, friction force equals to F equals to mu R, where mu equals to F upon R. So what we will do, we will change the value of F by R to mu here also and in the denominator also. So this equation will changes into tan theta plus mu upon 1 minus mu tan theta equals to V square upon RG. Okay, so what we have to find, we have to find the value of speed over here. So RG will go towards the numerator, so the formula will changes into, right. So this is the formula of the speed, right. Now if the when there is no friction, when there is no friction between the road and the tires, the mu will be the 0, and this formula will get changes into V equals to under root RG tan theta, right. So the angle of banking, the angle of banking or the minimum wear and tear of the tires, so that can occur, then the tan theta equals to V square upon RG, or we can say theta equals to tan inverse V square upon RG. So this is the angle of banking theta for minimum wear and tear of the tires. So the maximum velocity with which a vehicle can negotiate a circular road of radius r and banked at an angle theta is V equals to RG tan theta, right. So I hope I cleared your all of your maximum concepts over here. So thank you for giving me an opportunity, and all the best for all of your future.